That's it, yeah. I'm pushing the wrong button. Yeah, just to let you know, I can see it all right, but I studied electronics and then computer science at university, so I sort of sit a bit halfway in between some of these things. I taught computer science at the University of Kent for 37 years, and then Christchurch for 3 years after that. I did consultancy with various companies, so I have seen the real world. Dun and Bradstreet was one of them, that was quite lucrative. I did something for Pfizer while they were still... Right, yeah. I did something for Pfizer, which was also quite lucrative, and Premier Foods, they were rank holders with Doodle. I'm now retired, sort of, but I'm chair of the BCS, which is the British Computer Society, or it was, but they went all KFC on us. And I'm also a member of the Computer Conservation Society, which isn't exactly part of the BCS, but it's affiliated, and we use their rooms for free in London to have our meetings. So the computer conservation bit, of course, is the thing, and I think that's the clue that tonight, none of this is going to be useful in your career. But never mind, it's good fun. So, it's an attempt to show cheap ways of playing with old technology, and in fact, if you've got a lot of money, the not so cheap ways of playing with old technology, if you'd like to do that. Why? Well, because it's there, first of all, and because it's fun. There's some value of fun. Not everyone would always agree about that. It's educational, which might trigger one or two of you, and it really is interesting to learn about these things and learning how it used to be, and even some of the oldest of us will not actually remember some of this stuff. It's just before my time, mainly what I'm talking about tonight. In this case, I'm going to concentrate on one thing. I could talk about all sorts of things. I mean, they're rebuilding a computer at the CCS, which is actually the EDSAC, which goes back to the early 1950s, even late 1940s. I'm not going that far back. So what I'm going to do is just pick on one company, and that's a company called the Digital Equipment Corporation, who are very, very techy. They got called DEC for short. And what they didn't understand was actually how to make money all the time and how to see where the market was going. They thought PCs were a passing fad, which was a bad move. They also didn't quite get how to do marketing of certain items, and they didn't know when they were supposed to move their product line to something else. They're also quite expensive, but it's a very good product. So eventually they got bought out by Compaq. Compaq lasted about 3 or 4 more years, and they went and HP took them over. HP are still running, or still developing, or were till recently, one of DEC's operating systems. They've stopped doing that now, and another company have taken over. So I'm going to look at just really one, mainly, of their computers, which is pretty well the smallest one they ever produced. It's easiest to talk about. And I'm going to cover 3 things. Real hardware, replica hardware, and emulation together with emulation and hardware-software hybrids. And all these things are things you can play with yourself. So I'll just look at the examples we're going to do, first of all, and the machines we're going to look at. I've sort of, this is rather artificial, and I've even made up a word, machination, which is probably not right in this one. Where you play with real hardware. You actually buy yourself an old computer and play with it when it's still available and when it's affordable. Some of them are not available and some of them are definitely not affordable. If they are affordable, you probably can't afford the power bill, especially these days, right? Second one is replication, where you build a replica of that computer, and having built the replica, you can then run it just like the real thing. So you can do that with the original chips, if they're still available, and sometimes they are. You can do it with something called an FPGA, and I'll come back to that. Or you can just use small-scale components. I've seen somebody who's built a CPU out of very small-scale components, but done it in such a way that it fits on a board, sort of like that. But that's only a third of it. There are 3 boards, I think, might be 4. So you can see what's going on, but it's stupid. And the third part is emulation, where what you do here is you use software to emulate the original hardware. You can write a program to pretend to be a computer. Why not? You know, it's fairly easy to do. It might be quite big, but it's still an easy thing to do. And one of the nice things you can do is do a hybrid. You can actually build on some hardware that connects to that software, so you get the the experience of using the original computer as closely as possible. And I'll share a couple of examples of that. So that's what we're going to look at. And then I've got a conclusion after that, a very short one. So, as I said, mainly from the Digital Equipment Corporation of Maynard, Massachusetts. They started off making little logic cards because their venture capitalists wouldn't let them build computers because they thought there's no way we're going to compete with IBM, right? And they've got an old wool mill in Massachusetts, in Maynard, and they massive place. They had a bit of a problem actually because on hot days, because it had been a woolen mill for 200 years or something, on hot days you used to get lanolin dripping from the ceiling, which was a bit of a problem. But yeah, that was DEC. I'll mention some other later DEC machines, but the PDP-8 is the main one. The PDP-8 is the one that probably one of the most successful early machines. Why are they called PDPs? Well, the venture capitalists wouldn't let them call them computers, so they're programmed data processors, right? And they stuck with that all the way through until, well, 20 years on anyway. The PDP-10, which is a big machine, and the PDP-11, which is definitely their most successful machine ever. So I'll talk about those briefly. I'll touch on other systems as well, because some of them are quite interesting. Now, some of the stuff I'm going to show you is actually related to hardware that was originally designed by a guy called Oscar Vermeulen. He came and gave a talk in London, which I couldn't go to because I had a hospital appointment I waited 10 months for. But he was very kind afterwards and said, well, I'm quite happy to send you the slides. If you want to use any of them, that's fine. So I did. And you'll see that he designed a couple of things, the PDP-8 and the PDP-11. You probably guess what they are. So, what about DEC? Well, their culture was that, possibly because of this thing about doing the logic boards to start with, was that they were very, very engineering and technical based. And you could actually get a book for practically everything from them. They would give you circuit diagrams, they would give you free books which had all sorts of interesting details about how to build a system in software and everything else. And I collected quite a lot of those over the time I was an undergraduate. And I really wanted the PDP-8, but they were, you know, $20,000 or something. I didn't have $20,000. But there was one in the University of Kent at the time, running a mass spectrometer. And they've got books for everything, you know, and a lot of them are now online. If you go to bitsavers.org, you can go and get lots of DEC stuff. They started off very small, just a few employees. They got up to 140,000 employees in 1987, and they were gone by 1998, completely into compact and pretty well. That was on the skids as well. They just didn't keep up with how the markets were going. They started off in 1959 with the PDP-1, which was based on a machine called the TXO from MIT. And I think they made two of those. One of them was used by the telephone company, the big telephone company. The PDP-8 family in 1965, 28th of April to be precise, was a 12-bit computer. And it was mainly designed as a lab computer, so that meant that, again, they gave you all this engineering information, so you could build your own peripherals and do everything else you wanted to do with it. So it was actually a microcontroller, but you could also do real work with it, and people did. The PDP-10 family, just to give an example of another one, 1966, was a 36-bit machine. Why 36 bits? Well, a lot of their early machines, including the PDP-1, were 18-bit machines. They just, well, let's double it. You know, we've got the logic boards. You know, it'll be cheaper, right? And it's essentially a mainframe, and it occupied a pretty large room, like most mainframes. And then there's a PDP-11, which was 1970. That was a 16-bit mini computer, and it was one of the early mini computers. There were others, Data General Nova, for example, which was quite popular. One or two others. But the PDP-11 had a really, really nice architecture, and its assembly language was a joy to behold. It was really easy to use and useful. And I've forgotten how many tens of thousands of those they sold, but they were going for a long, long time. I think right up to the 1990s they were still selling them. And then they went on to a 32-bit computer, the VAX, which stands for Vertical Address Extension. 32 bits is quite big, but everyone else was doing 32 bits, so they said, we'll do one. And that was as far as they got before they fell into the mire. So, quite an interesting company. So, let's go on to part one, which is the machination bit, which is actually getting real machines. If you're a really sad and rabid enthusiast, this is what you're going to do. You're going to get one of these. So you could go and get a PDP-11, for example. I've got 4. You could go and get a VAX. I've got 3. I haven't got much else apart from ZX81. But anyway, that's the ultimate target. But it's hard to come by these things. I bought one of them. The most expensive one was £250, but the nicest one was free, actually. Somebody just giving it away, and I just have to go up to Suffolk in the car and cram all this into the back of my car, including 2 massive disk drives. And mine consumes about 1.5 kilowatts. So, that's a lot for a machine that is a 16-bit computer with 56k byte memory and not a very powerful CPU. It also occupies a 42U rack, so it's a rack about that big. It's in my workshop. Something like the PDP-10 requires 3-phase power supply, so you have to then go to your electricity company and say, can I have a 3-phase power supply? And they say, well, that would be several £1,000, sir, and lay that into your house. So that could be a problem as well. There are some places where you just can't get 3-phase power. As an aside here, there was somebody who rescued an ICT mainframe from London and put it into a barn in Plutley. And he was not able to get 3-phase power at his farm, so he went to an RAF station and bought one of their emergency generators and stuck that outside humming away. But it's worth looking at where the story starts with these things. The PDP-8. This might be a bit disjointed because there's some of Oscar's slides in here as well. But the real PDP-8, the single most popular 60s and 70s mini-computer. This is about 3 years on from when it was released. And that's a PDP-8, a fairly minimal one. So you can see it's got all these nice keys on the front, these switches, because that's how you could put programs in if you wanted to. Most of them didn't have boot buttons, so if you wanted to boot it, the first thing you had to do was use those switches to key in several instructions so that you could actually start the machine. And down the left-hand side here, you can see what's on there is actually the numbers you need to key in. So it's right on the front panel. And the other thing about DEC is they had colour schemes. The basic PDP-8 was always this sort of brown and yellow type, orange and yellow type thing. PDP-11s were shades of red and purple. PDP-10s were shades of blue, and so on. And an awful lot of software concepts come from the PDP-8. You would recognise some of the things it does, even today. And if you had a laboratory, this is what you'd use. People got very attached to these things, and as I said, we have one running a mass spectrometer. What's interesting about that actually is I was trying to get hold of some more of these books, these free books, and the professor who had this in the university, a guy called John Todd, had retired, and he said, I've got a load of books for the PDP-8, would you like them? And I said, yes, please. He said, well, I come into the university occasionally, I'll bring them in. And we spent about 2 years missing each other for one reason or another. And then he moved house, and I said, well, can you get them now, after you move? He said, well, no, he said, they're in the garage, but they're behind a mass spectrometer, as you do. But anyway, we finally identified that we were going to be in the same place at the same time, one very cold January. And there we were in the car park of Thanet Crematorium, at the funeral of my previous head of department, who would have thought this was hysterically funny, transshipping books after the funeral. Anyway, so the thing about the PDP-8, it was around for so long that it evolved a great deal. You started off with paper tape. How many people know about paper tape? Not that many, right. So you've got a tape about an inch wide, paper tape in a big roll, and it's got 8 holes, up to 8 holes punched across it, plus a little, what used to have a sprocket hole, it was for a gear to fit into the holes. Later on it just used for timing. And that was how you loaded things in. It predates punch cards. Right? And that would be on a teletype. We'd prepare that on a teletype, which was a 10 character per second keyboard and printer device with a paper tape reader and punch on the side. We'll see one in a minute. And then they moved on to having, about 1969-70, a disk operating system called OS8. And then they moved on to having much smaller machines as the technology got better. So it spanned a lot of different things. Why would you want a PDP-8? Well, it shows how things work at the lowest level. That's an extended teletype. The bit on the right there is the keyboard, as you can see, and it's got a paper tape punch next to it. And you can see it's one of the later ones that it's actually got it's standing a little stand on its own. The early ones were a full rack. It shows where we came from, of course. It shows PDP-8 was on the cusp of developing smaller computers. It was very concise programming. PDP-8 had 4K words of memory in its basic form. In its most extended form, it had 32K words. And it's amazing what you can do in 32K words. You do a tremendous amount. But you had to be clever. And when you consider a simple operation in Windows these days is going to take many megabytes of code, you think, well, something's gone wrong somewhere. And of course, it's got what they call blinking lights. You've got proper lights on the front, which you can actually see. You can see what's going on. It's very comforting to see those lights. The only other thing I find comforting is loudspeakers. One of our mainframes had a loudspeaker and we had a volume control on it, and the operators turned it down, but I always used to turn it up because I could listen to that and say, it's going to crash in a minute. I was always right. And I know that with an earlier computer we had, the first Kent mainframe that I used, which was an ICL 4130, the guy who was system software manager, who was my sworn enemy because I was always hacking into the system, and quite successfully actually. He came into when I was a postgrad and I was allowed in the computer room, he came in one day and we started it out and he said, ooh, it's only clearing 32K of memory just by listening to the listening to the noise. It was a funny thing, he left actually when I became a member of staff. These two things are not connected. When he left, he was a member of the Royal Horticultural Society. He was a fellow, actually. He went into basically looking after his garden and things. But he came back for a leaving do about 20 years later, which time I was Master of Darwin College, and I ran a goodbye dinner for a load of staff. And he came up to me, he said, oh, what are you doing these days, Bob? I said, well, I work here. Oh, he said, what do you teach? I said, operating systems. He said, why am I not surprised? And that was just sort of typical, very dry humour, the guy. But blinking lights are great fun and quite useful. So let's have a look at the front panel in a bit more detail. This is just the right-hand corner of the panel. And one of the things about the PDP-8 is it's only got eight different machine instructions. And that's why there are 8 lights, because you can see which instruction it's executing or which light's on. Right? Which is stupid. There we are. Some people know about something called the fetch-execute cycle, which is where you fetch the instruction from memory, then you execute it. So these lights tell you where it is at the moment. And it tells you whether it's running and everything else. These things are all about what's happening internally. You can single-step programs. There's I forgot which one it is. That switch there. It's spring-loaded. Every time you press it, it executes one more machine instruction, so you see what's going on. That's rather good. You can see the execute instructions, as I said. You can see and set the CPU registers and change the contents of memory from these switches, right? So you can halt the program, patch it to make it work, and then set it going again, which again is great fun. So you're really close to the hardware. It affords efficient coding, and unlike these chips these days, you can actually see what's going on inside, right? Which is quite good. So, what can it do? Well, you can program it with various languages. I'm not quite sure where the cat came from, but there they are. But we have cats at home much the same way. They're always pressing the enter key when they shouldn't. So you could program an assembly language. It had a basic system, quite good basic. It had Fortran, right, which is a pretty large language. Something called Focal, which I'll come back to. Algol, which was a language really that got standardized in 1960 and was used for probably about 20 odd years after that. Lisp, which is what we would now call an AI language, I guess. Forth, which is a sort of niche language, which is still around and quite nice to use. Focal was the interesting one. They invented Focal. And the idea of Focal was that you had an all-in-one, load it into the memory and just use it, which is better than some of the alternatives. What you can see up here is another panel, which you can see has got a green colour scheme. That was the laboratory equipment that you could connect to it. It was something called a Link 8, which was a laboratory instrument computer. It was effectively a PDPA attached to something else. So that's the two together. So you could do quite a lot of stuff running your laboratory equipment. Had an operating system called OS8, as I said before. What's interesting about OS8 is that it's really the ancestor of CPM. If you come across CPM, that was the ancestor of MS-DOS. And so you'll see in a bit that the things like the way the file names are arranged, everything else, are still here today for us in Windows. Right? The way this did things has really leached all the way through into the modern day. They had a multi-user operating system running in 32K, supporting up to 17 users. It was called TSS-8. I'll come back to that in a minute. The earliest chess game that we can trace, called Checkmo, I know nothing about it, had the earliest adventure game. Anybody come across Colossal Cave? This is the earliest version of Colossal Cave, or a similar kind of thing, and it inspired the actual Colossal Cave. And the earliest video game called Space War, which is what you're seeing on there. That's actually the Space War sort of on a graphics display that you get for the PDPA. So, it's the machine, if you like, that went all the way through from the paper tape phase, right at the beginning, where everything you did was involve loading paper tape into memory and running it and everything else, and then back to a personal computer afterwards. It was sort of after the evolutionary direction was clear, if you like, but before everything got settled. So the architecture of the PDPA is a bit weird compared to some other things. First mass market computer, they made 50 or 60,000 in the end, I think. So there's quite a wide audience for these things. And they kept the open source mindset. Well, certainly for the first 20 odd years, and then it began to get a bit difficult. And it gave many computing pioneers their first experience of playing computing, and converted a lot of people to doing computing instead of doing something else, like physics or something. Or electronics, or multimedia technology and design. So anyway, the paper tape bit, first of all, 1966, the way you ran a program was, first of all, you loaded the tape into memory for the editor program and prepared your source code and punched it out on paper tape at 10 characters per second. Then you would load the tape for the assembler program in at 10 characters per second, so 10 bytes per second into memory. The assembler would run, hopefully assemble correctly, and you get a binary tape of your program. Of course, if it didn't work, you'd go run those first three again. Then you load the binary tape back into memory and detect your bug. Then you go run the whole loop again. So you just keep doing that. By 1968, they'd got Focal was around, and Focal was in memory the whole time. You could compile and run your program and just use it. And then later on, interactive programming. You imagine how bad it was before that, but it was the first real interactive programming where you could sit down and do proper things on a small computer, without fiddling around. Then it evolved, and they had something called a deck tape. I was going to bring a deck tape with me, but I had a space problem. This is a deck tape drive, and those reels you see there are about that big. And the tapes are 3/4 inch wide, and they've got individual blocks on them which you can address. So they work just like a floppy disk, and you can have a filing system on them. It's not like the conventional tapes, which are just sort of, you record stuff on and then you record over it. And it was low tech. They held 360K, so as much as a double-sided, double-density 5¼ floppy. And you could have an operating system running off one. I built an operating system on one once. The teletype got replaced by a video terminal, and the original editor, called Tico, was replaced by something called WPSA, which was a rather nice word processing system. Tico is an editor which you can still get on Unix. Its commands are all single characters, and practically every character you care to name is a command, including the control characters. If you write a script for Tico, it looks like line noise. I'm quite good at Tico because I decided to learn it back in the 70s. So it began to morph into what we would see now as a personal computer. Now, the multi-user operating system, TSS-8, a student did this in 1968. He was taking the piss out of IBM. IBM had a system called, what was it? Something SS, TSS 360, that's right, yes, for the IBM 360 mainframe. And they said, look, time-sharing system, TSS 360. And the student turned around and said, we've got one, it's called TSS-8, it runs in 32K. You know, and 17 users running virtual machines. And, you know, it was quite ridiculous they could do that. They built hardware all the way up to 1990 for the PDP-8. They started off with diode transistor logic, which was individual components, transistors and diodes. Then they used the 7-4 series logic, which are the early chips, which in an 18-pin chip would give you 4 AND gates, so not very much. Then in a single chip microprocessor, which was the Intercell 6100 and then the 6120. But they're all the same PDP-8 pretty well. The later ones were slightly enhanced instruction-wise. And then 50 years of active service, there are still PDP-8s running. A 1970s PDP-8 was still running in Holland in 2016 doing CNC, and there's still a guy making money servicing PDP-8s in Germany. So, you know, it's a long-lived machine. Okay, that's probably a good place to stop, and then I'll go on to the replication bit. We're about halfway through, so that's all right. Okay. Sure.